Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by B2B Energy. My name is Paul Webb, and I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you energy experts from around the world. Welcome to episode 153. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. Welcome, energy enthusiasts, to another enlightening episode of Energy Speaks Back, where we delve deep into our guests' origin and their knowledge within our industry. Today, we are featuring yet another future technology that is here today and has been a big part of the energy history, and that is wind energy. So without any further ado, let's blow those cobwebs away and glide into the conversation with Robert Baxter.
Good afternoon, Rob. How are you today?
I'm doing great, Paul. Thanks so much for having me on your show.
Well, thank you for joining us. I'm really looking forward to talking about this subject of wind, which we've had a bit of a tongue-in-cheek joke behind the scenes. Quite good way to start the call, really. So thank you very much for joining us. What's the weather like? Have you just woken up there?
Yeah, today, well, I'm going to give you, our numbers, which used to be your numbers. So it's about 62 degrees Fahrenheit here,
Right.
which is warmer for you than it is. And we're coming off of a summer, and I'm thin-blooded, so it's a little chilly, but cloudy, but still all good. All good. I'm trying to squeeze the last bit of summer, out of the season here. So it's all good.
We're the same, actually. We're just coming out of our summer. Well, we didn't really have much of a summer. Did you have a good summer this year there?
We had a beautiful summer, and believe it or not, compared to last summer, not to go down a tangent, but last summer it was very cool for us because we had a lot of the wildfires in Canada blowing quite a bit. It was, even though we're hundreds and hundreds of miles south of Eastern Canada, it was noticeably cooler, and the sky was hazy. It was like a heavy fog, even again, like it was so far away. This year we didn't have that, so you could see it in our gardens and in the weather. It was just everything was warmer and sunnier, and it made a big difference. So yeah. So this summer has been a great season for us.
So $1 million question here. Are you seeing signs of climate change in where you live?
Yeah, we do. Well, again, because I'm a little older, and and this is not scientific and it's purely anecdotal, but I live in New England in the U.S. and lots of ponds, and I live in Rhode Island, which is predominantly a bay, right, where it's So when I was a little guy, we used to be able to walk across coves, and we used to play ice hockey on frozen ponds, and I would say that ended. I think the last time I went pond skating was probably around early 1990s. So and my kids are college age and a little bit older. They never had that. So we've seen it. Again, it's anecdotal. I can't but surely it's been noticeable, at least where I live.
Yeah, it's funny you say about the age thing. Going back, because I can remember we used to see quite a lot of snow in the UK, especially around Christmas, and the fact of the white Christmas. We hardly see that. In fact, Christmas area is quite mild. And in I remember when my children were growing up, they never see snow at a really early age. And so it definitely is something happening in our world, isn't there?
Yeah, it seems like it. Like I said, I don't have, this is not scientific. It's based on my local, narrow perspective.
Your experiences, isn't it?
But yeah, we notice warmer, weather during the winter. That's more tangible for us. And the other thing we seem to, again, can't put a finger on it, but again, where we live is a coastal, coastal estuary. And, we tend to get more floods, more high water during, if the tides line up and with the storms, you'll see more
Yeah, yeah.
flooding, erosion, and stuff like that. But
Mm.
I'm not sure. Like I said, that has a little bit of a little bit more broader
Yeah.
perspective. But it just feels like it. It just feels like it. So, but
Yeah.
yeah, it seems like there's definitely something going
Change.
on. Yeah.
Definitely change, as we can say. So Rob, we've met through LinkedIn, which most of my interviewees come through that route. We've had a little bit of a chat from some emails and some conversation, but for the benefit of the audience today, can you give us some background to you as an individual and your origin story and how you've got into this industry?
Yeah. Well, I'll start there. So, my background, my original background, I graduated with a degree in electrical engineering, and I realized really quick that the engineers don't make decisions, and I moved into product management, product marketing. My graduate degrees in finance, got an MBA with a concentration in finance, and I worked along those lines in business development and things like that. Around 2010, I started a consulting company, did some other stuff, but one of our early clients was a company who wanted to get into the residential wind market. So that was our entree, and that led to a follow-on client that was an island resort, and this resort was paying probably one of the highest fully burdened rates for power, almost in the world. And
Mhm.
as a result, what happened was this resort couldn't offer competitively, power intensive amenities like air conditioning, and at the time,
Yeah.
big plasma TVs and all of this other, just the stuff that people like. So he asked us to look at what renewable energy options were available for him. And we spent about a year or so researching the island and meeting with the local government and the local stakeholders and the folks who were concerned about specific wildlife. And the island was so heavily regulated in terms of architecture, in terms of noise, in terms of all these things, that standard or traditional wind and solar, renewable energy technologies weren't allowable. So we concepted what has turned into our hidden in plain sight, our wind energy structure. And he's like, yeah, this is great, but I don't want to be the first guy. And you can't blame him. He
Yeah,
wanted
yeah.
that was already commercialized. But we looked at it and said, hey, this is something that we should work on. So over the subsequent years, and there was a lot of just life gets in the way too. There's a lot of things going on, but we worked with local universities. We refined the technology. We've commercialized it. We've been lucky enough, fortunate enough we've won a couple contracts with the United States Air Force to help further the technology along. And as a result, we're commercializing again what we call this hidden in plain sight wind energy technology. And the difference is that where most vertical or even horizontal axis wind turbines, they use blades to intercept the weight. So the principle behind wind energy, right? Just to kind of go back to basics, because
Yeah.
to generate more electrical power, you need to intercept more wind. And traditional wind turbines, whether they're vertical axis or horizontal axis, they do this by making the blades larger.
Yeah.
The problem is the larger you make the blades, the more issues you have, right? You need more wind to get the blades going. Then you need to start them. Then to stop them is an issue, because in high winds, so they end up being tuned for a very narrow bandwidth of wind energy. And then they annoy people and people don't like them. So you end up putting them, out here,
Yeah.
out either in the mountains or in the ocean, right? And then you have to run, expensive transportation, to
To get to 'em.
pull the power back to the consumers, right? It's a pain in the neck. I'm being silly. It's a pain in the neck, right?
Yeah.
So there's got to be another solution. So we looked at it, and we're a real big believer in distributed wind energy, right? So if you can produce the power, adjacent to the consumer, right? That's kind of our vision, our goal, and that allows you to take advantage of wind, to harvest wind where existing technologies aren't compatible, right? So we're silent. We're not. We don't vibrate a building. There's all sorts of things. We're wildlife friendly, right? We don't. There's no bird strikes, no collisions for a lot of different reasons we can talk about. So
There's all that. There's all those steps back from size, noise, etc. Does that then mean we've got to downsize the power output? Is there a penalty for that? That's what I'm referring to.
well, so yeah, I'm with you. So our launch, right? So we could scale up the technology, and we've played with, all right, how do you what does it look like, and we've quoted a couple of projects, but what we're finding is again, because we're so different, right? In order to enter the market, you need to be able to have a lower hurdle, and the way we've kind of lowered that hurdle for us is to have smaller form factors. So 8-10 kilowatt systems, which will power a house, a good big home, or a small village, because we're looking at that. That was one. And then the other thing is to, let's say, go where there's maximum pain, but I don't mean that in a negative way, but
Yeah.
maximum power. Energy security is a problem. Grid is unreliable, threatened by hurricanes and storms or other natural disasters. So go where there's maximum pain, but where traditional renewable energy and wind alternatives are not an option.
Mm.
And so that's what we've done. So our system, we call our rapid response system, is a fully wired, collapsible. I'm skipping a step, but it's a fully wired and collapsible system. So if you can kind of picture like an umbrella, how an umbrella collapses. So, but this would be a system that is, ultimately going to be 4 meters by an inlet of 4 meters by 6 meters, collapsed down, but fully wired, tested, inverter, battery storage, so you can, figuratively push it off the back of a plane and put it on an island in the Caribbean after a hurricane, and produce power, or push it off the back of a plane to some, place where there's civil strife, and there's the need for power for fresh water or to refrigerate food and medicine, and you've got power, right? So that's kind of our our initial application. Or out here in the U.S., we have underrepresented communities, like along the north coast of, going back to one of our initial question, off the northern coast of Alaska, we have indigenous peoples, these isolated villages, and we were
specified
for a grant project. We're waiting to see if it gets awarded, but these are folks who pretty much run small villages off of diesel generators. So we're looking at those types of applications, and then ultimately, when we see adoption, and we can demonstrate to the to the overall or the average consumer, then we can see these things a little bit larger scale on tops of, say, apartment buildings, or in residential neighborhoods, on top of, or adjacent to houses. Again, if you look at the wind atlas, this, that there's the, all pretty much all around the world, right? There's where the plains are. So in the U.S. and Canada, where you have Saskatchewan and the Dakotas and whatnot, right? There's an abundant wind, very little power density, and in other words, power consumption density, right? People are spread out because you've got farm, it's agricultural, and so those types of places are ideal for us also because you have, it doesn't make sense again to build out a big centrally generated, expensive transmission infrastructure. It makes a lot of sense now for a grid to put distributed generation, co-generation type systems out there. So again, I'm going around, but that's kind of where we're at. And then when we see that people get comfortable with that, we'll look at broader applications. Because again, we've seen there's different plans out there for carbon neutrality goals or environmental climate goals by 2030. The U.S. is one 2035. The only way we're going to do that, right? And I've got 2 points along these lines. The only way we're going to do that is if we look at a technology that is really truly able to be broadly adopted. And frankly, on a distributed scale. And frankly, horizontal axis wind turbines are not that. Our key competitors, and we've talked to these guys, they are limited to, say, 2-acre plots because they generate so much noise, they can't put them any closer together. That is not, and there it's a unit that goes on a monopole. You're not going to put that in a residential neighborhood, right? So in order to hit our climate goals, we need, right? There's don't get me wrong. I want to make sure I complete honestly. There's a place for horizontal axis wind turbines. We're not displacing them. But we need a technology that checks off all the boxes, can survive a hurricane. We didn't talk about that, but because we use an enclosure, we've got a stable geometric structure, and the materials we use are hardened. We can survive a Category 5 hurricane in the Caribbean, for instance. It's a building system. If you want, again, broad adoption, it's a building system. Nobody buys a house and expects the electrical system or the heating system to die after 10 years or in a big storm, right? They're looking for a system that's going to survive and last as long as the building, and buildings last 50, 60, 80 years. And so we need to start changing our mentality about wind energy and renewable energy go ahead.
What about vibration? Because when you're looking at putting wind turbines onto buildings, you've got this vibration issue, haven't you? And do you have that with your system, or have you looked at that?
No, I'm glad you brought that up, Paul. So that was one of the challenges of our initial system. So I'm going to take a step back, right? So with a wind turbine, or any type of product, there are two different design philosophies I call it, right? So if you've ever gone to a big banquet or a big party, there's a waiter, and the waiter's got a tray. The tray is precisely balanced, and it's got all your cocktails and your drinks, and they're bobbing and weaving, right? But don't take anything off the tray.
He has to do that. Yeah,
that's a traditional wind turbine, right? The other person we don't pay attention to at the banquet is the busboy. Busboy has got a big tub with two hands down below their center of gravity, right? And they're bumping into you, and right, and that's okay. That's our design philosophy. And so when you get into so our system is designed to vibrate. We know most of our system, by the way, is made out of a flexible geomembrane that is used, for instance, in the bottom of hovercrafts or inflatable boats, or to line. It's actually used to line toxic waste, catch basins outside. So it's got all resistance and UV resistance. Anyways, so we absorb a lot of the so our system's designed to vibrate, designed to work out of balance, designed to take a log at airborne in a storm, and be flexible. And we've got and we know the rotor is going to be out of balance if there's it's also hydrophobic, but in case there's any kind of precipitation buildup, frozen, whatever, it's designed to vibrate and shake it off. But then what we do is we isolate that vibration, and the way we anchor the system, it negates it. So there's no vibration transmitted from the rotor, right? The rotor is the actual thing that's going to vibrate. It's designed to vibrate. There's no vibration transmitted through to the building, and the same thing because of that. The same a result of that design philosophy or the design approach is we're also silent. I mean, I've stood, directly adjacent to our system, operating in, say, like 20, 30 mile an hour winds, and there's no noise from the system above the ambient wind noise going, past our ears. So the key issues you mentioned, like vibration, noise, shadow flicker is another key thing, and we eliminate because our rotor is in an enclosed system. There's no shadow flicker.
Right.
I think
one of so I've been a consultant and been looking at organisations, and obviously that wind's always on the agenda, but it's understanding how do we, for instance, if we wanted to put solar on the roof, we can go to various different data services to provide us with forecasted daylight. And we know when the sun's going to come up, we know when it's going to go down, we know roughly the coverage of sun we're going to get. Do we have the same sort of data for wind? Can we predict wind, or is that a challenge?
Yes and yes. So there are publicly available resources out there, and the one that I like is Wind Atlas. It's a public, you can there's a subscriber variant, but if you're just somebody who's interested, there's a free variant. You can go, and it's an online resource, and you see the whole world, and you can zoom into your,
like a Google Earth type thing.
And what's that?
It's like a Google Earth. You have the whole world, and you can zoom into. Right.
That's a great way to put it. Exactly right. It's like, and you can get down to 10 meters, which is 10-meter hub height, which would be kind of where we'd be at, right? So that's the first yes. But the second yes, which is the problem, is as great as that is, if I took like a wind, because we've seen this, right? Took a wind turbine and put it next to my garage, or put it in my grove of fir trees, and so I've got trees around, right? It's like, it's not
the wind is there, but it's been deflected.
Yeah, exactly.
At source, yeah,
exactly. So we always talk about how do you validate the public resource in the specific location where you're going to be, and that might be with putting your own wind logger up, and capturing the data, and some of it's just intuitive, like I'm next to a big barn, I'm going to have to do something different, so.
And is there such thing as wind loggers?
Yes. Oh yeah, we have one that we recommend in the US, and then there would be, because it's very rudimentary and basic, and most people can put some batteries in it, plug it in, plug your USB cable in after a few months, and download the table, and we'll look at it.
And is it like one of these things with the prongs, and it's got the little cups on the end, and it spins round? Am I being too?
It's got a propeller-based anemometer with a weather vane, and it's got a little data logger in there, and so you set it up so that the thing points north. And it collects the direction, and it collects the date, time, direction, wind speed, every minute. The maximum or the gust for that minute data, and I think so you get the average, the gust, direction, that sort of thing. So it gives you a very, again, rudimentary. That they're only like
Yeah,
a couple.
I like that word.
Yep. So it's
And then interesting, I'm very interested in this actually because I've got loads of buildings in my head. Now, okay, we get the logger, set it all up, leave it for, how long should we leave it for? 12 months, maybe?
well, 12 months is ideal.
Yeah,
A lot of people don't want to take that amount of time, but 12 months is
yeah.
ideal.
So we get a whole complete, all the seasons all brought into one. And
Yeah,
then what?
Yeah, go ahead.
No, go on. Yes,
I was
but
going to say because wind is very seasonal, right?
yeah,
Because
yeah,
it depends
yeah,
on where you're at in the world, and spring, fall, summer, winter. You have these different things going on, and if you're close like we are to the shore, the oceans kind of affect that.
yeah.
So to really capture what's happening, you should look at it for
And
years.
then what's our, this is the next thing for me. What's the trigger point regarding how was the speed? So 3 miles an hour, 10, 20, 30, constants. What are the sort of things? So presumably we can get that data and then say, right, if we had all that data there, that would generate X. Is that how you do
Yeah,
it?
yeah. So every, not just us, right? So every wind turbine has a power curve,
Right.
and their spec sheet will normally have how much power their curve, their system will generate in we'll call the standard, right? There's an industry standard wind characteristic. When you send somebody, like say, a year's worth of data, they can build the characteristic wind curve for your location, right?
Mm-hmm.
And then it's essentially, and that curve basically says, okay, 1 mile an hour, so many hours over the course of the year. 2 miles an hour, so many hours per year, right? So you've got this distribution of hours versus wind speed. Then you take the what they'll do is and I'm oversimplifying a little bit, but they'll take the power curve, which says, okay, at X wind speed, the wind system generates 1 kilowatt, 2 kilowatts, 3, right? So they got that. So now they can multiply, using the wind speed, they can multiply kilowatt output times hours, and that will give you a sense of what the power production will be over the course of a year, how many kilowatt hours the system will produce.
Yeah.
And then you can determine then, is your system a good match for your wind? So, and I'm going to make up, an absurd example, but like the very large utility grade wind turbines, they need steady laminar wind, 20 miles an hour. So they're up high, which is great for them, right? So if you tried to put one of those down below where it's more turbulent and the wind speeds, there's not going to be a good fit. You would see very little power production, or not. It wouldn't be great. And so it's up to then, the project manager and consultant and whatever to say, okay, this is not a good fit for your location, but this would be a good fit for your location. And for us,
would there be a plus or minus on that? Because that was in 2000. So we've been doing that, and I'll come to you. Here's my data for 2023, 24. Going into 24, 25, is there a plus or minus? It could be more, it could be less. Do we know those figures? How can we forecast? How do we do it? What do we do about forecasting that?
It's tough. And generally what what the industry does, right, is just we make an assumption that average curve is repeatable, year to year to year. So there's there are certain sites that will give historical data, right? So there are some resources that have like logged years and years worth of data, but that's tougher, and it's not as readily available.
This device logger is it respectable pricing?
Well, the one that we talk about, and again, this is very rudimentary, is about a couple $100.
Right.
The probably like a more like a first class data, anemometer, wind logger,
Yeah.
might range, you know, maybe about $1,000. So it's
Yeah.
still not talking tons of money. And
'Cause-
if you were in the business, that would be reusable. You could redeploy
yeah.
that.
Well, I'm just thinking about something that maybe if you've got a building, so I've got a building now that I'm thinking of in the back of my mind. We've talked about wind. We've dismissed wind because of the cost. Okay, that's one big thing regarding wind technology in the UK. Okay, and as you mentioned before, the two, we've got the vertical and then we've got the big horizontals. We're not where this particular building. We're not going to put a horizontal. There'll be a big uproar if we started doing things like that. But we could do it with the verticals. I can see that easily. However, everyone's always said too much money, cost. However, it is a lot of money to do that. But why not start monitoring now, as of today? We could, as you say, spend not necessarily a couple of $100, but from a couple of £100, but you've got me on that now. A couple of £100 to maybe £1,000 to put some loggers on our buildings, because maybe one day, 5 years, 10 years down the road, we've got all this data. We could then put that in front of a technology provider and then go, oh, that's brilliant. And then we can see exactly how constant that data has been or not.
You're right on. And if it's a taller type of a building, like in the city,
Yeah.
You might get more wind than you think.
Yeah.
So that's,
well, we have, again, this is where I'm thinking about this building. We have what I call wind tunnels. When we're walking down towards the building on a really windy day, we're having to walk again. It's like taking your breath away. And they're the areas where I would think, well, that'd be brilliant to put. They don't have trees down there because they've taken the trees out because the trees just blow over. And we could put like a row of windmills, I call them windmill, whatever
that works.
Yeah.
But
you could monitor that area, couldn't you?
Yep,
now,
absolutely.
today, just to start. There's no point waiting. There's no point for us to wait 5 years down the line so I had this conversation all the time regarding new technology. Okay, we could still say windmills are not new technology, but they are in today's world.
Yeah.
Technology cost there is very significantly higher, and quality not so. Yeah. Over a period of time, 5 years time, they'll be matching each other, and we should be looking at them. However, we haven't got the data. But if we start now looking at the data, which is low cost monitoring, there's no reason. So for me, you just triggered something in my mind. We need to get our organizations that we're working with to start looking at wind. If they're an opportunity, don't say no. Say no to installing, but yes to monitoring and measuring.
Yeah, I think that's a great idea, Paul. Absolutely, because you're setting the the foundation, and with very little cost, you're just giving yourself options later on in the future. So why don't you? By the way, you could use that data for more than just evaluating a potential wind project, right? You're talking about, like, so you have issues with trees falling over, or with just maybe wind load, and this would give you some quantitative data, that might help some of the other, adjacent engineering fields for some other problems.
Exactly. Oh, well, that data could be valuable to anyone in the area as well, couldn't it?
Yeah. So,
it's funny, data's so king, isn't it, in this world? And everything we talk about, whatever technology, data's king. We can't make any decisions without this data.
Yeah, right. And we should, right. That's also a pet peeve of mine, right? We should be making data-driven decisions, and not say, again, it's one of the things we run into. Oh, it's a wind turbine, and so we're gonna rule it out, or this is how I feel about it. It's like, whoa, right? Let's look at, let's look at, the data, and then let's make a rational decision, an informed decision, based on, the constraints that we have, the needs, and what options we have. So I love that idea. I think it's a great idea. And if if I'm a renewable energy firm in that area, that's a service that you can offer. You
Yeah.
know, with a very little commitment from your customer base.
So I'm guessing your challenges that you have is it education and going from the data to solution process. Is
Well,
that the biggest challenge, or do you have other challenges around that?
well, I would characterize our biggest challenge as trust, and the
Right.
reason why, and again, I don't know if this is particular to our market, but you know, especially like in the early when the wind technologies started coming out, early 2000s, mid 2000, 2010, they there were a lot of just just be polite, a lot of not good options out there, and
Right.
people people lost money and the things broke and whatever, and so here we are as a very unconventional, very different technology,
Mm.
and our biggest hurdle is to build trust. To we make a lot of claims, and we can back those claims, but what people want to see is, uh, you know, they want to see other people. They want to see it working someplace else, and
Yeah.
and that and that's the way we're overcoming that is like we said in these this rapid response variant, and then in
Yeah.
these other
And
areas.
and
Because
building case studies really is that's where you need to grow the confidence as such as and especially when you have a case study where you've got a commercial building case study. Well, this commercial building you're talking to, this company here, they've done it. Look, they've proved it works. So that starts building the like and trust. And I must think that you've got a big mountain to climb there, haven't you? Because there's not a lot of them around. We
no,
don't see that.
and then in the U.S., uh, we there's a very significant amount of regulation over, um, you know, introducing a new wind technology into
Mm.
the market. It's very expensive, and
Yeah.
it's very onerous, and so that's and again, those regulations are in place because, and I think this maybe I'm seeing it a little bit more harsh than it is, but because the industry broke trust with the market, these regulations
Yeah.
were the result, and so now it's just that's tough.
So is your operation predominantly in the UK sorry, in the US currently? Have you branched out? You looked at any global type projects?
Well, we have there yes, so we've got three kind of projects that are in the hopper. I'll say they're very conceptual, but we're
Mm.
talking with folks at different um, potential partners in Europe and in other places, a couple of other continents, and we're trying real hard to make those work. So again, because the opportunities fit with our
Yeah.
our unique technology and the needs for those areas. So yeah.
Where can I go and look at your technologies? Because I'd like to, when we do the videos for this, I'd like to probably link in some of the case studies you've done and some of the pictures you've done. Where's some key areas that you've done?
Well, sure. Well, so the first place to go would be our website and YouTube channel, but the website is just cbcwindenergy.com.
Right.
And that gives, and there's like a storm resiliency white paper up there, and things like that. And then we do a lot on LinkedIn, as you know.
Yeah.
So we're always posting on there. As far as let's see, we probably the next big thing to kind of keep a lookout for to see where we're going is we've got a deployment with um, uh, the latest version of our rapid response variant that we're currently in the process of building out. We're going to ship it at well, I was going to say the end of this year, probably January. It's going down to Florida.
Right. So I was going to ask you, can you tell us about the future? What has the future look for you guys?
Yeah. So I mean, we're always optimistic. I mean, we don't know what tomorrow's going to hold, right? Because there's a lot of things going on in this world, but we're optimistic. And like I said, so we are we are looking at taking this rapid response variant, which again is if you can picture, it collapses kind of like an umbrella, opens up a big thing.
Yeah.
But you can tow it onto a cargo plane. It's got flyable battery storage. It's pre-wired, so it's plug and play.
Right.
And we're looking at, we've got what I'll call some Department of Defense, some NGO, non-governmental organizations that we're looking at selling those to right out of the gate. We also have a distributor that we're working with in Puerto Rico, and we're looking at, because again, they have just they're so challenged with hurricane resilience. They're right in the crosshairs of the hurricanes that come through. Their grid really still hasn't recovered fully from where it was at prior to, it was 2019 and hurricanes Irma and then Maria. And so we see a big opportunity there, and we're working with them to take what I'll call a variant of our rapid response system, because we want to be able to ship it there, but they don't need all of the other kind of accoutrements to go along with it, and to make a I don't want to call it residential, but like a residential commercial version for businesses. They have they're not windy all over, but they have, again, we using the tools that we talked about, like the Wind Atlas. We've identified key areas of Puerto Rico and other islands, other island communities north and south that we feel would be good markets. And then we're doing the same thing. We're looking at these off-grid, I mentioned, like the Dakotas in the U.S. that where you're 100 miles away from anything, but you need power. So it's because our system doesn't need a foundation, right? You can just drop it in place, and it's a good solution for that. So those are the humanitarian aid, crisis response, off-grid applications because of storm resiliency, or off-grid applications because there's no grid. But that's kind of where we're going, and we've got.
It's funny, when I asked that question, I had this answer in my head. I thought you could have said, "Well, it depends what way the wind is blowing. That's where our future is going." But I thought, I can't have too many. I do apologise. Yeah. Where's your future? Well, we don't know what way the wind's blowing yet. Let's find out. Yeah. So no, I can't. Sorry. So Rob, this has really been amazing, and I'm feeling quite good inside because I want to be able to offer these services, and I've always got wind on my questions when I ask an organisation under renewables and that side of it, and it's such a great resource. As I said, we walk down to these buildings and blown back, and I think, why can't we use these? Why can't we use this? So anyway, it's come to that stage. Thank you very much. There's some great content there, and I think you should come back again and talk some other areas. But it's come to that stage where I'd like to just put you on the spot, and you've been brilliant. You've been well on the spot. Is there anything you can give back to our industry today regarding the takeaway for them?
Yeah, I mean, we talked a little bit about like the the challenges of someone who's got a great idea, a great solution, and so the first thing I would offer is, for anybody who's got a great idea, right, who can make a difference, I encourage you to be flexible and be persistent. And our thing is we might not get there, right, tomorrow, but slow and steady wins the race. Just a little bit of forward progress every day. And I know that that's tough. Renewable energy, it's an excellent opportunity. But it, like I said, here, there's a lot of, we have a lot of inertia that we need to overcome. And so, so stick with it. So that would be the first thing. And, I guess, I think that's probably be the biggest thing, to work through, be patient, to work through the customers who are skeptical and the investors who are skeptical, and just, do your due diligence and
I think it's a little bit, we need to bend it a little bit as well. So we need to be consistent. We need to keep going, and we don't need to be perfect, but we need to be prolific. Okay. There's no room in this to be perfect currently. We will get there, but there's this, we need to take different directions and move it. We need to move that line, the needle needs to move, doesn't it?
I like that, Paul. And then that also reminds me too. I alluded to this earlier. We tend to compete with one. We tend to think in competitive terms, as an industry. And I would say, listen, to achieve our renewable energy and our climate goals, we need to jettison that mentality, because there's room for, right, to complement each other, right? The energy infrastructure of the future is going to have solar and wind and who knows what else, and there's going to be centrally located utility grade generation, and there's going to be distributed generation, and everything in the middle. So we, as an industry, we kind of get parochial and say, what, we're gonna block this guy out, or this is really competitive.
We need to work. We don't need competitors.
Right.
We need to work with them, collaborate.
Yep. And I mean, and to that end, I mean, we're like, our rapid response variant we're working on right now, because somebody asked for it. He says, can you put solar on it? Like,
why not?
Yeah, exactly. So we'll work with just, so that's the, I think that's, I think that's where we need to go, as our industry organizations, our trade organizations, we need to kind of say, okay, let's be a little bit more open-minded. There's a bigger goal out there than just us in our little pond. So,
well, Rob, I'd like to say thank you very much today. As I said, breath of fresh. Oh God, you said breath of fresh air. Another little bit of a pun. I do apologise for that, listeners, but it's a breath of fresh air, because I've been desperate to interview someone in this industry who would be prepared to come out and talk about this. And for me, this challenge has got smaller, because I think it's something that we can all achieve now. And I like some of the things that have come out from there. The takeaway for me is, let's start monitoring now on our buildings, and that's a great thing for me to sort of take on board myself. So thank you very much. It's been a real pleasure, and thank you for making the time today.
Oh, thanks for having me.
Brilliant. And please, Rob, you and your family, stay safe in these times.
Same to you. Thanks, Paul.
Thank you to my guest for joining me on Energy Speaks Back. I hope you found today's insights valuable. And don't forget, please listen to the previous episodes, because they're full of insights to help you make a real impact on energy efficiency. Together we can drive change and make a difference to the environment and our planet. So thank you once again. That leaves me with one more thing to say. Please, you and your family, stay safe in these times.